Hi everybody. The video for today is going to be a couple extra examples on how to factor by double grouping, or this is also called factoring by grouping. In the examples we're going to be taking a look at today, each expression that we're going to factor is going to have four different terms. So in the first example, I see 1, 2, 3, 4 terms. They're separated by plus signs and minus signs. What we're going to do to factor by grouping is we are going to group together the first two terms and the last two terms. And when we take a look at the first group, we want to figure out in the first group what is the GCF. So in the first term, I just have letters, x cubed. In the second term, I have x squared. So between the letters, I want to find the GCF, the letter with the lowest exponent. So it's going to be x squared. And then I want to factor out that GCF from the first term. So remember, factoring out the GCF means dividing each term in the first group by that GCF, x squared. So x cubed divided by x squared, same base. We're dividing the same base, meaning we want to subtract the exponents. So 3 minus 2 would give me x to the first power. And then I'm going to copy the sign, minus. X squared divided by x squared would give me x to the 0 power, which would technically be 1. But I still have a 9 there, so I'm going to copy down the 9. In terms of the second group now, we want to figure out what the GCF is. So this one, the first term has 5x, the second term has 45. So there's no letter here for the second one. So now I just want to take a look at the numbers and figure out what is the GCF between 5 and 45. Both of them are divisible by 5. So I'm going to copy this symbol, the plus sign here, and put a plus 5. And I'm going to divide out from this group a 5 from each term. So 5 divided by 5 gives me 1, or x, because there's an x still left. I'm going to copy down the minus symbol. And 45 divided by 5 is going to give me 9. So what you want to take a look at when you figured out the GCF and divided it out from each group is you want to take a look at the terms in parentheses. Are they the same thing? If they are the same thing, you have factored by grouping correctly. The last step then is going to be to take this common factor, x minus 9, and write it down once. And then I'm going to put a second set of parentheses behind it. And in the second set of parentheses, I'm going to put together the other terms that were in front of that set of parentheses. So I'm going to put x squared, that's in front of the first set, and then a plus 5, which is in front of the second set. And that's going to be my final answer. So we're going to go through a couple examples here of factoring by grouping. So again, I'm going to group together the first two terms and then the last two terms. And in each group, we need to find the GCF. So 3 and 2 have no common factors other than 1. X to the fourth and x squared, I want to take the letter with the smallest exponent, so x squared. And I'm going to divide out an x squared from everything in that first group. So I'm still going to have a 3. X to the 4 minus 2 is 2. X squared divided by x squared is going to give me x to the 0, which would be 1, but I still have a minus 2. Second group, I'm going to copy that plus sign down, and I'm going to look at the GCF of the second group. So x squared is here, but there's no letter here. So the GCF is just going to be a number. 15 and 10 both have a common factor of 5. So I'm going to put a plus 5 and divide out the plus 5 from everything in the second group. Put a parentheses down. 15 divided by 5 is going to give me 3. X squared on the side. I'm going to copy the minus symbol down, and then 10 divided by 5 is going to give me 2. So again, we want to check, is what we have in parentheses the same exact thing? Yes, it is. So I'm going to take that set of parentheses for my final answer and write it one time. And to figure out what goes in the second set of parentheses, I'm going to take what is in front of the parentheses. So x squared plus 5. That's going to be my final answer. All right, so a couple more examples here. So again, we have 4 terms. We are going to group together the first 2 terms and the last 2 terms and find the GCF of each group. So the GCF of the first group, x cubed, x squared, is going to be the letter with the lowest exponent, so x squared. I want to divide out x squared from everything in that first group. X cubed divided by x squared is going to give me x to the first by subtracting the exponents. I'm going to copy the minus symbol. X squared divided by x squared is going to give me x to the 0, which is just 1, but I still have a 2 there. Now, this one, the symbol that I see in the next group is a minus, so I am going to put a minus symbol here. And then when I take a look at the group here, I want to find the GCF. So 8 and 16 both have a common factor of 8. Now, I'm going to divide out a minus 8 from everything in that second group. So negative 8 divided by a negative 8 is going to be 1, but I have an x on the side, so it's going to be 1x. Positive 16 divided by negative 8 is going to give me a negative 2. So again, when this is a minus symbol, we do need to divide by a negative and a negative here. That's going to be different than the last 2 examples because we had a plus sign here. Now we have a negative sign. You want to check, do we have the same term in parentheses? Yes, we do. So for our final answer, I'm going to write that term one time. To figure out what goes in the last set of parentheses, I'm going to put together the 2 things that were in front of the set of parentheses. There's my final answer. We're going to do another one like that with the minus symbol. So group together your first 2 terms and your last 2 terms. Find the GCF of each group. Well, 6 and 3 both have a common factor of 3. But I also have a GCF that involves a letter. So x cubed and x squared, we want to take the letter with the lowest exponent. So I'm going to divide everything in this first group by 3x squared. 6 divided by 3 is 2. X cubed divided by x squared is going to give me x to the first. Copy down the minus symbol. 3 divided by 3 is 1. X squared divided by x squared is x to the 0, which is also 1. Next group has a minus in front, so I'm going to copy that minus symbol down. 4 and 2 both have a common factor of 2. The GCF for the second group is not going to involve a letter because the second term in the second group does not have any letters with it. So again, because this is a minus symbol, I want to divide everything in this second term by a minus 2. Negative 4 divided by negative 2 is going to give me a positive 2 with an x on the side. Positive 2 divided by a negative 2 is going to give me a minus 1. You want to check, are the terms that you have in parentheses the same exact thing? Yes, they are. So for the final answer, I'm going to write that term I see in the parentheses one time. For my second set of parentheses, I'm going to put together what I had in front of the parentheses. So 3x squared minus 2. The last thing I want to talk about quickly is prime polynomials. So a polynomial is considered prime if you cannot group the terms and factor them in a way to get a common binomial or common terms in parentheses. So if I were to start this process by grouping like we have done, I'd want to figure out what the GCF of each group is. So 2 and 9 don't have any common factors. X cubed and x squared, we take the term with the lowest exponent and then divide that out. So this would give me 2x plus 9. In the second group, 8 and 9 do not have any common factors other than 1. This has an x, but this doesn't. So technically, the GCF is just 1 there. But notice that what I have in parentheses here are not the same thing. 2x and 8x are not the same term. So because this set of parentheses does not match this set of parentheses exactly, we would say that this is a prime polynomial because we are unable to factor by grouping. Again, for all the examples we did up here, when we factored out the GCF, we got the same exact term in the set of parentheses, which does not happen here. That is why for this last example, this is a prime polynomial.